Okay, so now we're gonna do a different thing. The last video we did a manual clustering and check that with the tSNE results. Now we're going to do a k-means clustering and check that with the tSNE results. And in order to do that, I've developed a script that does just that. I mean, there's quite a lot of code in it, which I don't want to explain in great detail. Although you can look at it and work out the details. It's not very complicated if you're reasonably proficient with Python. But even if you're not and you want to use this script, the important thing is you can change these variables, these parameters, and use it for different types of data set. Okay, so you can easily use it for other ones. You just have to change those parameters. K, that's the number of clusters, and obviously we calculated that for this data set in the last lecture using the silhouette and elbow methods. But obviously you can decide what that's going to be. You could even run the tSNE to try and see what it thinks are the clusters. The ratings, or how many clusters it seems to show in its pictures. The raw data is the ratings. The perplexities are those values we saw. Again, if you've got a larger data set, you probably need higher perplexities. And because this data is getting a bit too involved, I'm not going to put labels all over it. So I've left this as an option here. We can annotate the charts, the scatter plots, or not, and I've turned it off for this one. So you can easily change this script if you want to apply it to other ones. Okay, so the first thing to do is create the clusters in the using the k-means algorithm. So as I say, we've decided how many we're going to have, and there's various ways of doing that. But we now create those clusters, those 4 clusters in this case, and put them in into a list of clusters. So this clusters list contains those four data frames, each one representing a cluster. Next, we do the perplexity embeddings. Okay, so for each perplexity value that you've put in that list, we can create an embedding, and then we embed those. We create the embedded clusters is a list of the clusters embedded in the two-dimensional plane. So embedded clusters is a list of those embeddings, but restricted to each cluster. Okay, and that's stored in its own separate data frame. And then in that same loop, so this loop is looping over the 4 perplexities, I create a scatter plot where I take each embedded cluster and then draw that cluster in a different color. Okay, so every cluster that I've created from the k-means clustering, I've then embedded embedded with tSNE. I've built a data frame for that particular cluster, and then I do a scatter of that cluster. And every time you do a new scatter plot in one of these subplots, you'll get a different color. And as you can see, if annotate is set to true, then it will also label all the data points. But I've turned that off for this particular example. Okay, as I say, if I haven't explained it very well, or you're not very confident with Python, you don't really need to adjust this bit of the code. This code should work for different kinds of data set. You just need to adjust those parameters at the top, so the k, the perplexity values, and where the data comes from. So when I run it, here's the results, and this is hopefully you'll see is quite interesting. The k-means algorithm is generating 4 clusters, which are shown red, green, orange, and blue. And the tSNE embedding is embedding those clusters close together. So both algorithms agree about what are similar data points. The low rated and the high rated. So just knowing that the order that these things come in, I think I had to label them to find out which was which. But the low rated and the high rated end up being in blue and red clusters respectively, and those are always grouped together. Okay, so we know that low rated products and high rated products form a cluster of similar data points. The other two clusters are again, I think I've had to do this. Oh, I've done it. I've said here by printing out the contents of the cluster. So that's one way of doing it. The other way would be to label these data points with using the annotate flag. If I set that to true, then all these will be labeled. Sometimes that's not practical though, if you've got very large amount of data. So the other clusters are CIP, Q, UV, Y, and this list here. I'm not going to read them out. And so we've got some similarities between those products in terms of their ratings, but we don't know what it is. It's not just a case of simply taking the average. That didn't work. But this is good news so far, because we can see that tSNE and k-means are agreeing about how this data should be clustered. Doesn't always happen, but in this particular case, it has. Okay, let's finish that video there, and then we'll look at how we can then interpret those results even better.